Hi guys, so today we're gonna be eliminating arbitrary constants from different equations so that we can get their equivalent differential equation. Now the steps here in eliminating arbitrary constants are very easy. The first step is to count the number of arbitrary constants present in the equation, and that will tell us how many times we will differentiate our equation. Now for the step 2, if there is still an arbitrary constant present in the equation, we will use the different equations we have so that we will arrive with an answer that is free from arbitrary constants. Let's now apply the steps on the first problem. Eliminate the arbitrary constants in the equation x cubed minus 3xy minus k equals 0. For the first step, let's determine the number of arbitrary constants. And by looking at the equation, we can see here that we only have one, and that is the term containing k. Now for its solution, we will only have to differentiate this equation once. So I will apply the differentiation in every term. So I will have here the derivative of x cubed minus, for the second term, I will factor out 3. Then I will get the derivative of xy, then minus the derivative of k equals 0. Now, to differentiate the first term, we will use what we call the power rule. And the power rule states that if you have a function equal to x raised to n, its derivative is n times x raised to n minus 1. And applying the power rule on the first term, the derivative of x cubed would be 3x squared. As for the second term, we will use here the product rule. Now, the product rule states that if you have functions multiplied together, for example, u and v, its derivative is u times the derivative of b plus v times derivative of u. So if I apply product rule on xy, what I will do here is I will just assign a function for my u and v. And for this case, I will let u equal to x and v equal to y. And the next step here is to determine the derivative of u and v. So the derivative of u here is, since we have here x, that would be 1. And the derivative of v here, and since I'm using here the prime notation, the derivative of y here would be equal to y prime. So plugging in these values of u, v, and derivative of u and v, the derivative of xy would be u times dv, or u times the derivative of v, would be equal to x times y prime plus v times derivative of u would be y times 1. So the answer here would be xy prime plus y. I can now plug this derivative on the equation. So I will have here negative 3 multiplied by xy prime plus y. As for the third term, derivative of a constant is 0. So I will have here 0 equals 0. Next is I can now distribute negative 3 from this equation. So I will have 3x squared minus 3xy prime minus 3y equals 0. Now the last step here, since all of the coefficients in the term are all equal to 3, I can reduce them by multiplying both sides by 1/3 so that I can cancel out all the coefficients of the term. So the final answer here is x squared minus xy minus y equals 0. Let's now solve problem number 2. For this problem, we have here the equation 1 plus ay equals x squared y. Again, the first step here is to count the number of arbitrary constants. And by looking at the equation, we only have one, and that would be the constant a. So it means for its solution, we will only have to differentiate our equation once. So I will start with the left side of the equation. I will have here the derivative of 1 with respect to x plus the derivative of ay with respect to x. Then on the right side, that will be the derivative of x squared y with respect to x. For the first term, the derivative of 1 or the derivative of a constant is just equal to 0. As for the second term, we know that the derivative of y with respect to x is just equal to y prime. So it means the derivative of ay is equal to a y prime. As for the right side of the equation, we will use here the product rule. And again, it states that if you have two functions that are multiplied together, let's say u and v, its derivative is u times derivative of b plus v times derivative of u. So letting my u equal to x squared and v equal to y. So let's solve their derivative. So I will start with the derivative of u. So since u is equal to x squared, the derivative of u would be 2x. And as for the derivative of v, that would be y prime. So I can now solve the derivative of x squared y by following the product rule. So I will start with u times derivative of b. That would be x squared y prime plus v times derivative of u. That would be y times 2x. Simplifying, I will have your x squared y prime plus 2xy. So I will place it on my right side of the equation. So x squared y prime plus 2xy. So now I have here the first order differential equation. And if you notice, we still have this arbitrary constant. Now, in order for us to eliminate this arbitrary constant, we can use here the original equation. So from the original equation, I will try to isolate a from the original equations. I will have here 1 plus ay equals x squared y. Transposing 1 on the right side of the equation, I will have ay equals x squared y minus 1. Dividing both sides by y, I will have here a equal to x squared y over y. That would just be x squared. Then minus 1 over. So I've distributed the denominator on both the terms in the numerator. So I can now use this value of y and substitute it to the first order differential equation. So if I do that, I will have here x squared minus 1 over y multiplied by y prime equals x squared y prime plus 2xy. Okay? So distributing y prime, I will have your x squared y prime minus y prime over y equals x squared y prime plus 2xy. So notice we have the same terms here on both sides of the equation, so I can cancel them out. So leaving me with negative y prime over y equals 2xy. Now, the final steps here is we need to remove here the denominator, then equate our equation to 0. So I will start by multiplying both sides by y so that I can cancel this denominator. So I will have here negative y prime equals 2xy squared. So that would be y times y, that would be y squared. Then last step, so I will just transpose this negative y prime to the right side of the equation. So the final answer here is 2xy squared plus y prime equals 0. For problem number 3, eliminate the arbitrary constants in the equation y equals a cosine kx plus b sine kx, where k here is a parameter not to be eliminated. And since we have that condition, our number of arbitrary constants would just be equal to 2. And that would be the constants A and B. So for our solution, we will just need to differentiate this equation twice. So I will start with the first derivative. So let's get the derivative of y, then equate it to, for the first term here on the right side of the equation, I will factor out a, then get the derivative of cosine kx. Then for the third term here on the equation, I will factor out b and get the derivative of sine kx. On the left side of the equation, derivative of y is just y prime. As for the right side of the equation, we need to know the derivative of, or we will use here the derivative of cosine u. And that would just be negative sine u times derivative of u. Now we will have to assign a function for u, and that would be kx. So if u is equal to kx, the derivative of u would just be equal to k. If I have here cosine kx, its derivative would be negative sine kx times k. Or if I simplify this one, this would be equal to negative k sine kx. Okay. So the derivative here would be, if I plug in this derivative here, that would be negative a k sine kx. As for the last term, we will use here the derivative of sine u, which is equal to cosine u times du. Our u here is still kx, and its derivative is still k. So if I have here derivative of sine kx, it will be equal to cosine kx times k, or this is simply k cosine kx. So using this derivative of sine kx, I will have here my third term equal to b k cosine kx. So this is now my first derivative. Let's now solve the second derivative of this equation. Derivative of y prime is just y double prime. As for the right side of the equation, I will factor out negative ak, then differentiate once again sine kx. Now for the third term, factor out bk, then differentiate cosine kx. We've already solved the derivative of sine kx and cosine kx. We will just plug it in this equation. So I will have negative ak times derivative of sine kx, that would be k cosine kx, plus bk times derivative of cosine kx, that would be negative k sine kx. Simplifying my second derivative, I would have here negative ak squared cosine kx plus, or sorry, minus bk squared sine kx. So notice in our equation, we have common factors negative k squared. So I can factor out here negative k squared. Then I will be left here with a cosine kx plus b sine kx. Notice, a cosine kx plus b sine kx is just our original equation. So it means I can replace this function here with y. So I will be left with y double prime equals negative k squared y. And for my final answer, I will just equate this equation to 0. So I will transpose here negative k squared y to the left side. So my final answer is y double prime plus k squared y equals 0. So we now have an answer that is free from the constant a and b.